point in our discussion, that is the total differential. Okay, now as usual we have this f to be a function of, sorry, I'm writing it here, f is a function of two independent variables x and y. So as usual this x and y are independent variable and f is the dependent variable. Now in physics or in any other physical phenomenon, it is available or it is possible that both x and y change simultaneously. Change, this word is very important, simultaneously. In earlier discussion we have taken separate x changes, y remains constant, whereas in the second case y changes and x remains constant. This time both x and y changes to x plus delta x and y changes to y plus delta y. If you want you can write this, तुम्हाला हवं असेल तर तुम्ही हे लिहून घेऊ शकता, लिहाच म्हणजे, because without writing we won't understand this type of mathematical differential equations, and therefore because of this both of these are changing, therefore this capital F changes to f plus delta f. So dependent variable changes by delta f because independent variables x and y are changing simultaneously by delta x and delta y respectively. Okay, then we can write the relationship or the function as, okay, then I can write f plus delta f is now a function of a changed variable x plus delta x and y plus delta y. So both x changes and y changes simultaneously, and therefore there is a change in f is calculated, and this is going to be f plus delta f. Further we can rearrange this as delta f can be written as f of x plus delta x and y plus delta y minus f. Now this f from our first this derivation, this equation, I can write this to be simply f of xy because capital F is function of x and y. Okay, now one important step here we have to go, we are subtracting and adding something on the right hand side of this above equation. Okay, now what is that? I will just rearrange this as follows. So write further, subtracting, okay, and adding. So first subtract and adding. Okay, now look at this quantity, function of x and y plus delta y. So here x is same, y changing by y plus y delta y, and therefore new function is obtained to be f of x and y plus delta y on RHS, right hand side of above equation. Okay, and let's see what we get. We get, see what I'll write here. So this delta f can be written as this is f of x plus delta x and y, y plus delta y, this is first bracket, minus, I'm subtracting this above quantity, f of x and y plus delta y plus f of x and y plus delta y. So this is subtracted and this is added. This is allowed in mathematics because adding and subtracting the same quantity doesn't make change in the mathematical equation. So this fact I am using, and therefore this subtraction and addition of this term is shown to be as shown by this. And now minus last is f of x and y. So look at this here, x in the last two terms x remains same, y changes from y to y plus delta y, this is negative, this is positive. Here y plus delta y remains same in both the case, and x changes from x to x plus delta x, and negative sign is here. So this term I am taking a change with respect to variable x, and these remaining two terms I am taking a change with respect to a term delta y. So y changes, x remains constant in the last two terms. First two terms x changes and y remains constant. So this type of methodology I'm able to take here. Now further, next arrangement is like this. So we have to write in the square bracket, divide this first two terms by delta x and again multiply by delta x. So on the right hand side, if I divide and multiply any of the term by same term, then it also remains unchanged. So that particular mathematical fact I am using here as following: f of x plus delta x and y plus delta y minus f of x and y plus delta y. Okay, this is to be divided by delta x and it is to be multiplied by delta x. This is allowed in mathematics because I am dividing and multiplying this by same term, so this doesn't make any change in our equation. Plus for the second term, exactly similar I am writing here, f of x and y plus delta y minus f of x and y divided by this bracket should be like this, divided by delta y into this is multiplied by delta y. So look at this, I can write this left hand side is, therefore it is delta f is equal to this. Now we are changing this changes in x and y to be very small, and then in the limit we can use the limiting values and we can get the further derivations as follows. Okay, now here, okay, so something different is coming. It is here. Okay, once we get familiar with this board, how to operate this will become more simpler. Okay, now let's write one statement. Now consider a case when this delta x and delta y are made extremely small, okay, then let us write approximately. Remember why to write this in mathematics, this is allowed. So we change delta x by small delta x, delta y by small dy, and small delta f, this is by df. So this changes I am taking in the above equation. So when delta x tends to 0, made as small as possible, as well as delta y is made as small as possible, approaching towards 0, then in the limit we can write above equation as this left hand side will be replaced by df, right hand side can be written as limit delta x tends to 0, then this bracket is f of x plus delta x and y plus delta y minus f of xy divided by delta x, and write the delta x out of the bracket by this dx. Similarly for the next term, limit delta y tends to 0, bracket f of x and y plus delta y minus f of xy divided by this is delta y into this is dy. Now look the terms in the bracket. Now these terms say you something very special. What is that? This term here is nothing but, okay, I am writing it very short here, this is partial derivative with respect to x. Okay, so let me correct this. Actually Sometimes this board also doesn't work. Sorry, we have gone out. This happens. Let me begin once again. So the quantities that we have written in the bracket, these were the actually partial derivatives. We can understand or we can note that. Okay, so this is what the part coming here. Yeah, further. So this first term in the bracket is partial derivative with respect to x, and second term in the bracket is also partial derivative with respect to y. Okay, so I can write here first term is partial derivative with respect to x, and second term is partial differential with respect to y. With respect to y. So if it is the case, then I can write this df is equal to, okay, I am skipping this, this is not needed. This left hand side is df is equal to, in the bracket, this is partial differentiation of f with respect to x keeping y constant into dx, plus second term in the bracket with limit delta y tends to 0, this term in the bracket, this gives you partial differentiation of f with respect to y keeping x constant multiplied by dy, or in short we can write final expression as df is equal to, this is nothing but fx into dx plus this is fy into dy. Remember, this is our final expression, which is called as the total differential. Okay, so we write here the quantity expressed in the equation by df, quantity expressed in the equation by df is called total differential of capital F. So capital F is the given function, its total differential is given when x and y both changes by delta x and delta y simultaneously. एकाच वेळेस दोघेही एकाच वेळेस चेंज होत आहेत, म्हणून जो चेंज होईल टोटल चेंज इन f, that is called as total differential, or that is what this equation. Okay, now this I'm extending this. If I have, we can very easily write this. If function f is a function of this time x, y and z, three independent variables, then the total differential df can be written as, can anyone guess how can we go for this? So first take partial differential of f with respect to x keeping y and z constant into dx, plus second differential is, second term is del by f upon del by y keeping x and z constant multiplied by dy. So third term is exactly similar, partial differential of f with respect to z keeping x and y constant multiplied by dz. So in simple language, this can be written as fx into dx plus fy into dy plus fz into dz. So these two equations are very important equation for this. So this is one square bracketed here and this is here. I am just underlining this. With this we can go for several simple calculations. Now how one can go for these calculations? Will go as follows. There is one numerical example we can get from our textbook. So let us consider a case of rectangle. Consider a case of a rectangle. Okay, a case of rectangle. The function for its area of rectangle, capital F, depends on its length and breadth. Its length, I am using two variables, length x and breadth y. So it depends upon these two. So therefore we can write expression for f is a product of, or this is f of xy can be written as a product of x and y. So this is the area of the rectangular, length into breadth, that gives you this area. Therefore its differential I can write, so f plus delta f can be written as a function of new variables x plus delta x and product of y plus delta y. Nothing difference. F is changing by df, therefore x and y both are changing by x is changing by delta x and y changing by delta y. So this is the product. Okay, this symbol should not be there, this is not there. So that x plus delta x into y plus delta y, this is simple product of a plus b into c plus d. So if I use that particular product, first will be, it is xy, x into y, plus then it is x into delta y, plus y into delta x, plus delta x into delta y. Okay, delta x into delta y. Now this f here on the left hand side can be taken on the right side, therefore I can write df is equal to, this is xy plus x into delta y plus y into delta x plus delta x into delta y minus this f is f of xy, or simply it can be written as x into y, since capital F is equal to x into y. This can be written here. So here that shows this and this goes. Here I am assuming, we can talk here further. So therefore change in area of the rectangle will be given by, I am writing it simply, it is y delta x first, then x delta y second time, and plus delta x into delta y. Okay. Remember, as our limiting case we have taken, as delta x tends to 0, delta y also tends to 0, this delta f becomes df, finite change, and therefore we can write sometimes this takes a time. So this equation, from this equation I can write in the limit, this will give you df is equal to, change in area is equal to y into dx plus x into dy plus dx into dy. Okay, the term, last term here, since dx and dy are infinitesimally small, therefore the product, that means if the terms itself are very small, their product is again very very small, then their product is negligible, so that can be discarded. This can be discarded, and therefore what remains is this df is equal to y into dx I'll write further. df can be written as y into dx plus x into dy, and this is nothing but df is equal to this is fx into dx and this is fy into dy. This is what our total differential equations. That means a very simple idea. This is my initial rectangular, this is x and this is y, and now this changes, x changes by amount delta x and y changes by amount delta y. Okay, so this is my x and this is y. Okay, so this is delta y here, this is delta x here, and this is the area, change in area. Now delta x and delta y may be positive or negative. If they are positive, then this area, okay, shown here, this will be more or positive. If delta x and delta x are negative, that means this, if it gets shrinked, becomes smaller. So this is the change in area. I can take this like it. So this change in area can be calculated by this equation. df is by dx plus x into dy, or this function f is going to be xy. So get differential of f with respect to x, you will get y. Get differential of f with respect to y, you will get x. Multiply it by dx, multiply it by dy, add them together, what we get is this change in the area. So geometrically, when a rectangle is given and its sides are changing, so x is changed by delta x and y changed by delta y, then what is the change in the area of that rectangle? That can be calculated by this total differential equation as given here. So geometrically what we have done here, mathematically what we have done here, and using this partial differentiation concept, we can find out this particular thing is as shown here. Okay, now there is one very simple and interesting problem after this. Actually there are a lot many problems associated with this total differential. I am not sure whether we will be able to cover this here in the lecture or not. So one simple example, we will go for this example. So who is there, whose mic is on? Kiran Maske or Pavan Mane, or is there anything? Kashitkar, say yes or no. Are you getting all these things? मी शिकवतो आहे सगळं समजतंय का? लिहिता येत आहे आणि हे म्हणजे चालू आहे ना, प्रोसेस चालू आहे का? नाही तर मी एकटं शिकवत राहायचो, तुम्ही सगळे तिकडे गायब, असं नको व्हायला. ओके, कारण मला आता गुगल मीट दिसत नाही, मला फक्त हा बोर्ड दिसतो, त्यामुळे मला कोण प्रेझेंट आहे कोण ॲबसेंट आहे इथं आता दिसत नाही, पण ते रेकॉर्ड आपलं प्रेझेंटेशन येतं नंतर. ओके, नाव यूज दिस, लेट्स यूज दिस फॉर्म्युला. फाइंड टोटल डिफरन्शियल ऑफ, find total differential of the given function. The function is very simple. F is equal to f of xy. Form of the function is this. It is going to be y exponential of x plus y. So this is the product of y and exponential of x plus y. This type of function is given. You have to find out its total differential. So let's go for the solution. So here I can find out partial differential of f with respect to x, keeping y constant. So what is this? Here y is not function of x, but exponential of x plus y is function of x. So, and we have seen exponential e raised to something, differential is e raised to something whatever, and differential whatever it is in the power. So e raised to what, that. So in the bracket its differential is also supposed to be taken. So y remains as it is, exponential of x plus y, and differential of x is simply 1. Therefore it is y times exponential of x plus y. Similarly obtained second partial differentiation, delta f upon delta y. Here y is function of y, and this exponential of x plus y is also function of y. Therefore you have to use this product rule for this differentiation. So first differentiating y with respect to y, I'll get 1 into exponential of x plus y will be as it is. Then second time this y will remain as it is, and exponential of x plus y will come after differentiation, multiplied by differentiation of this is again 1 with respect to y. Differential of this y with respect to y is 1. Differential of x with respect to x is not allowed. It's simply 0. That is not needed to be taken here. So this is how I get this y plus delta y. Y into exponential of x plus y multiplied by delta y, that is equal to 1. So therefore total differential df will be given by, as we know from this formula of total differential, it is delta f upon delta x into dx plus delta f upon delta y into dy. So write further what we got in above, what is delta f and delta x, so write it there, and therefore the total differential is given by, total differential is given by, you can write it there. Final expression is df is equal to, now see, it is delta f upon delta x is y exponential of x plus y into dx plus, this is, now there are two terms, exponential of x plus y plus y times exponential of x plus y into dy. This is my final expression for the value of df. Okay. Actually there are many other problems related to this differential, and this is one of the very important topic from this chapter. I think we will require at least one session over the problems to be solved there. In that case, one or two more problems will go here, as how this method can be used to solve different types of problems in geometry as well as in physics as well as in mathematics. Okay. Approximate calculations. Approximate calculations using differential or total differential. For example, we are going to see later on, आपण काही पुढे बघणार आहोत. For example, I am asked, this is आता आपल्याला माहिती आहे 6 square plus 8 square is 6 is 36 plus 64, that is equal to 100. Okay, that can be written as 10 square. Okay, this is I know. But if someone writes 6.01 square plus 8.02 square, naturally this will be more than 100, or it will be 10 point something. So what is this? So this approximate values can be calculated using this. So such type of problems we are going to discuss later on. Before that, there is one example I am going to discuss here, that is given in the solved section. So we'll go for this. Now this is another example number 3. Find approximately the value of 1 upon, sorry, this is 1 upon n plus 1 square minus 1 upon n square when n is equal to a very large number, 10 raised to 15. Okay, remember, we cannot solve this problem using calculator. So n is equal to 10 raised to 5, n plus 1 will be 10 raised to 10 raised to 15, n is equal to 10 raised to 15, n plus 1 will be 10 raised to 15 plus 1. We have to make it square, write them in denominator and get their differentiation. No way our scientific calculator can solve this type of mathematical problems, but using this partial differentiations or total differentiations, approximate value of this can be calculated as follows. How? That will be test here, or this as following. Solution. Now if function f of x, now there is single variable, only one variable x, and dependent variable is 1, independent variable is also 1. So this function can be written of the form 1 upon x square. So f of x is equal to 1 upon x square. Okay, and we are asked delta f is equal to function of 10 raised to 15 plus 1 minus function of 10 raised to 15. Okay, but from our definition of total differential, okay, we have this df is equal to partial derivative of f with respect to x into dx plus partial differentiation of f with respect to y into dy. Remember, I am having only one function. F is a function of small x only, so this part doesn't come, it's not there. Only this multiplied by dx will get changed here. So that is what I am using here, and therefore in this case this df can be written as d of capital F is 1 upon x square. So I can write this to be d of 1 upon x square into dx, okay, with x raised to 10, x is equal to 10 raised to 15, and dx is equal to simply 1, because we have been asked this is n plus 1 and this is n, so that dx is simply 1. I am taking n to be 10 raised to 15, and that order is required here. So f of 10 raised to 15 plus 1, if this function is calculated, we will get 10 raised to 15 plus 1 square in the denominator minus 1 upon 10 raised to 15 square. So getting this, I'll get this. Now differential of 1 upon x square, okay, differential of this is from mathematics, d by dx of 1 upon x is equal to minus 2 upon x square. D by dx of 1 upon x square is minus 3 upon x cube. Okay, I don't know how many of you know all these things. So here, getting differential of 1 upon x square, I'll get this to be minus 2. Okay, not that minus, this is minus 2. Here it is 1 upon minus x square, this is 2 upon x cube. So that gives you minus 2 upon x cube into dx, this differential. And therefore, since our x is equal to n, here we have taken, म्हणजे लिहिताना वरती n लिहिलंय, पण form of the function is this x square. So this is what I am taking here. N is equal to 10 raised to 15. So this is minus 2 upon 10 raised to 15 that raised to 3 into dx is 1. Okay, and therefore this gives you minus 2 upon 10 raised to 45, or that is equal to 2 into 10 raised to minus 45. So this is the approximate value of this difference between 1 upon n plus 1 square minus 1 upon n square, where n is a very large number, 10 raised to 15. Remember, whatever this number we have calculated, this is approximate, but there is no calculator available. Maybe in computer it is possible, but scientific calculator is not able to carry out this type of calculation. Okay, so write one line here, note that note that we cannot do this problem. We cannot do this problem on a calculator. Since we are subtracting two numbers which are nearly equal to each other. Okay, so on your calculator, try to work out this problem. This will give you answer to be 0. Calculator will give you answer to be 0. वर्कआउट तुम्ही प्रयत्न करून पहा, कुठल्याही कॅल्क्युलेटरने प्रयत्न करू नका. आन्सर ऑफ दिस विल बी सिम्पली इक्वल टू 0, बट वी नो दॅट वॉट एवर स्मॉल इट इज, दिस इज नॉट गोइंग टू बी 0. हा नंबर खूप छोटा असेल, 10⁻⁻45. यू कॅनॉट इमॅजिन हाऊ स्मॉल इट इज, बट इट इज नॉट 0. So theoretically it is not 0. Our practically calculator may give it to be 0, but this type of total differential functions or this total differential, we can find out the value of this difference will be approximately 2 into 10⁻⁻15. Okay, there is one more problem. I think there are 5 more minutes. Look, we are up to end. Okay. I'll take one more problem. एक छोटा सा प्रॉब्लम सोडूया. Actually problems are bigger. It is not possible to carry out this in 5 minutes. Let me check. There are lot many problems how to find out percentage error, then how to get a square root of, just like the problem what I have discussed, 6.01 square plus square root of 6.01 square plus 8.02 square. So this type of problems we are going to solve that type of problems in the lecture. Okay, today we'll stop here. Now I'm just stopping this lecture here, and then we'll take the attendance and all these things. So here